Okay, good morning. This is the final exam review for Math 0300. There is a Math 1300 final exam review just around the corner in A436. So if you're in the wrong place, okay, if you're in the wrong place, everybody get up that's in the wrong place and go to the correct final exam review. This is for Math 0300. Math 1300 is in A436, just around the corner. Anyone else in the wrong place? No. Okay, good. This is a final exam review. I hope that everybody has brought with them a hard copy of the final exam review. If you have not brought that with you, we have extra copies with Ms. Resnick. I am Bonnie Blumberg. We will be working on the final exam review together. We will also, before you leave, be handing out to you a copy of, or a mock final exam for you to work on. It also has the answers, so you can work on that on your own, check yourself, make sure you're doing okay. Before you leave, that's what we will be handing out. We will need to use most of this 3-hour period to work on the final exam review. And this is not a copy of the final exam. No question that's on this final exam review will look exactly like a question on the final exam. So you will also need to study all of your previous tests, your homework, look at your notes, your quizzes, and anything else that your teacher has given you to study. And you know that in my math lab, you can click on chapter contents and see the textbook. So you can go through some of the exercises in the textbook, because practice is the best way to know this material. Okay. So I'm going to be going over the frequently missed problems, or that are similar to frequently missed problems on the test, on the final exam. So let's look at number 1. We're given a set, and we need to find which are natural numbers. So we need to look at the differences between natural numbers and whole numbers. Natural numbers are the numbers that come naturally. Numbers that you would teach a 2-year-old. 1, 2, 3, 4, and so on. No fractions. 0 is not a part of that set. No negative numbers. And the set of whole numbers has one more element than the set of natural numbers. What element is that? 0, correct. So the set of whole numbers begins with 0, and it is essentially after 0, the set of natural numbers. So the only difference between the set of natural numbers and the set of whole numbers is that the set of whole numbers has one more element, 0. So we can say that the set of natural numbers is a subset of the set of whole numbers. It's a part of the set of whole numbers. And what does the set of integers look like? That has negative numbers and 0 and all the natural numbers. That should just be 3. Okay, and let's look first through our list of numbers and find the numbers that are natural numbers, set of natural numbers. So 14 over 2 we can simplify to be 7. So clearly that is an element of the natural numbers and an element of the whole numbers and an element of the integers. But natural numbers, that's going to be the first natural number in the set that we see. We can also simplify the square root of 64 and call that 8. So that is also a natural number. What is 1 over 0? Undefined. That is undefined. Remember that a good way to think about that is 0 on top is okay. No way. So the 0 in the denominator, this is undefined. 0 in the numerator equals 0. All right. So this is undefined. 2 over 6 will reduce to be 1/3. but it is not a natural number, whole number, or integer. 0 over 5, how do we reduce that? That's 0. Remember that this is okay, no way. 0 in the numerator is always 0. And nothing else will reduce there. So the set of natural numbers, looking at that list, would be 14 over 2. I guess we want to put it in the exact form that we see it. 14 over 2, square root of 64. Anything else? That appears to be it. Looking at the list of numbers, which of these will be whole numbers? 0, and also 14 over 2, square root of 64, 0 over 5, because that's 0. And that's it. What about integers from that list? Integers. Negative 20, negative 1, 0, and then of course 14 over 2, square root of 64, 0 over 5. Okay? Looking at the set of rational numbers, we need to look at the definition of rational numbers and irrational numbers at the same time. Rational numbers, the actual definition would be anything that can be written in the form of A over B. What does that mean? What is A over B? What is A over B? A fraction. So anything that can be written in the form of a fraction. Well, how could negative 20 be written as a fraction? The other way around. Negative 20 over 1. Correct. So all of our natural numbers, our whole numbers, and our integers would be considered rational because we could write them all with a denominator of 1. Anything over 1. Now, rational, the word rational is really anything that we can make sense of, anything that we understand, when it's not necessarily in a math sense. So, in addition to all of our natural numbers, whole numbers, and integers on the list, those will all be rational numbers, and fractions, anything that can be written in the form of A over B. When we look at decimals, a decimal, like 0.25, is considered rational because it has a beginning, it has an end. Now, that doesn't mean that a repeating decimal would not be rational, because a repeating decimal with a repeat that we understand would be considered rational, like 0.2222 and so on. If I asked you what the second place is or the hundredths place, you would tell me a 2. If I asked you what the thousandths place is, you would tell me a 2. The 10,000ths place, a 2. So we understand that. That's rational to us. So any decimal that has a repeat that we understand, that has a pattern, that is rational. Square root of 64, as we said, was 8. Of course, that's going to be rational. But the square root of 65 is 8.0 something something. That's irrational. If I asked everybody what the square root of 16 is, I hope all of you would tell me it's 4. If I asked you what the square root of 17 is, no one would have an answer for me. That's irrational. Okay? So looking at this list, we have, for rational, negative 20, negative 1, 0, 0.25, 14 over 2, square root of 64, 2/6 goes in there, right? 0 over 5 goes in there, and that's it. If we look at irrational numbers, we have negative square root of 3. What else do we have? Anything else? Square root of 19. What else? One more. Pi. Why is pi in there? No, it doesn't. If you were to divide 7 into 22, you will find, and we might as well put 22.00000 and so on, you will not find any pattern. It will not stop, and we will not see a pattern in any repeat there. So 7 goes into 22 3 times, that's 21 with 1 left over. 7 goes into 10 once with 3 left over. 7 goes into 30 4 times with 2 left over. 7 goes into 20 twice with 6 left over. 7 goes into 60 8 times with 4 left over, and so on. No repeat there. So that's why pi is irrational. Okay? Real numbers. Real numbers. Everything is real except what? Anything that's undefined. Everything on here is a real number. 1 over 0. Everything, all except 1 over 0. Because 1 over 0 is the only one on that list that's undefined. Okay? So are we clear on sets of numbers? Any questions? No? Okay. All right. Insert one of the symbols to make a true statement. -3 and -1. If you have to think about the number line, here's 0, here's -1, -2, -3, and as we move to the left, we are actually getting smaller. As we move to the left, we're actually getting smaller. So we want to point toward the smaller number. So -3 is less than -1. Now we read this as a sentence from left to right. And when we get to the symbol, we get to the small part of the symbol first. So that's why this sentence is read, -3 is less than -1. When we look at B, we have the absolute value of -5. What's the absolute value of -5? 5. What is the absolute value of 5? 5. It is not -5. Absolute value doesn't mean opposite. Absolute value means distance away from 0 on a number line. And distance is always measured in terms of positive numbers. So that's why absolute value is always positive. It's not the opposite. It's always positive. So when we look at 5 and 5, of course, they are equal. Now when we look at C, let me move that up for you. We have negative absolute value of -2. What that really means is the opposite of the absolute value of -2. Well, the opposite of the absolute value, since absolute value is always positive, the opposite of always positive will be negative. So you know that on the left-hand side you will have negative. In fact, you have -2. And on the right-hand side, we have the absolute value of -2, which is 2. So we are comparing -2 and 2. Clearly, the negative would be smaller than the positive, so we point toward the smaller number. Looking at D, 12 over 4, we can reduce to be 3. 15 over 5, numerator divided by denominator, is also 3. So therefore, 3 is equal to 3. Do a little something here. I see that my ink bleeds through. Okay, so 2/7 times 14, which we'll call 14 over 1. So we can multiply across and reduce when we are finished, because we do have to simplify our answers. Or we can take an intermediate step. You know that to reduce a fraction, you have to divide the numerator and denominator by the same number. And when you multiply, it can be any numerator and any denominator. So we know that 2 and 7 we cannot divide by the same number because they're both prime. Can't divide them by any number. But 14 and 7 we can divide by 7. Since 7 is prime, the only number that will go into 7 is 7. So 7 divided by 7 is 1, and 14 divided by 7 is 2. So now when we multiply across, we get 4 over 1. We don't need the 1 in the denominator because the question really is how many 1s are in 4? 4. 4 divided by 1 is still 4. Now when we divide fractions, well, we don't actually divide fractions. We multiply by the reciprocal. So the first thing we want to do is change this to a multiplication problem. So 7/3 multiplied by 15 over 1. Now we can work it the same way we just worked the previous problem. 7 and 3 do not have a common factor. There's nothing we can divide both 7 and 3 by. However, 15 and 3, we can divide both of those by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. So when we multiply across, we get 35 over 1, which simplifies to be 35. Remember, if you are going to take a test that says multiply and simplify, and you all are taking a 50-question test that is all multiple choice, one of the choices could be the answer that isn't simplified, and one of the choices could be the answer that is simplified. So if it clearly says multiply and simplify, multiplying isn't enough. You need to make sure you reduce all your fractions. Okay? Now in E, we're adding. So A was multiplication, D was division, E we are adding. And we can only add like fractions. We can only add thirds with thirds. So whenever you are adding or subtracting fractions, they must be like fractions. They must have the same denominator. You did not need to do that for multiplication or division. So 7/3 plus 8 more thirds all together is 15/3, which will simplify. 15 divided by 3 is 5. We don't need the 1 in the denominator. Now 7/3 plus 8/15 requires that we change the fraction so that it has a common denominator. So we need to change, looking at those denominators, 3 and 15, we need to change those fractions to have the LCD, the lowest common denominator. What's the first number that both 3 and 15 will divide into? And when you are building equivalent fractions, think big. It has to be a number that is 15 or larger. So if you were to count by 3s and count by 15s, the first one they would have in common is 15. And a little trick is if one denominator divides evenly into the other, choose the larger. Think big when you're finding LCD. And since 3 divides evenly into 15, choose 15. So the LCD here is 15. Well, the second fraction already has the denominator 15, so we don't need to do anything to that fraction. But we need to change the first fraction to an equivalent fraction with the denominator 15. So the only thing we have to compare are denominators. So 3 times what gives you 15? Times 5. So if you multiply the denominator by 5 to get the new denominator, you have to multiply the numerator by 5, 7 times 5, to get the new numerator, which is 35. So now we have like fractions, so we can join them. So 35/15 plus 8 more of those 15ths is how many 15ths? 43/15. And we can leave our answer as 43 over 15. Look at your answer choices. If all of your answer choices are improper fractions, then you certainly can leave your answer as 43 over 15. 43 is prime, so 15 won't divide into 43, and neither will any other number. If your answers, when you look at your answer choices, are mixed numerals, then you need to change this improper fraction to a mixed numeral by dividing. 15 goes into 43 twice. 2 times 15 is 30. Subtract and get 13. That's your remainder. So when we're talking about 15ths, it goes in 2 times, and we have 13 of those 15 left over. So Your answer could be 2 and 13/15 or 43/15, depending upon whether your answer choices on the question are improper fractions or mixed numerals. We have the same problem in H, but it is subtraction. So remember that we changed 7/3 to 35/15, and we left 8/15 exactly the same because now we can subtract like fractions. So 35/15 minus 8/15 will be how many 15ths? 27/15. Now that does reduce because there exists a number that divides both 27 and 15, which is 3. So when we divide 27 and 15 by 3, we get 9/5. Now, you should try and find the greatest common factor that divides both 27 and 15. In this case, it's just 3. But you should, after you divide numerator and denominator by the same number, check and see if maybe there exists a number that will divide what you have left again. So that you should always check all your fractions and make sure that they are in simplest form. Because you may not be coming up with the greatest common factor, just a common factor. So you might have to do it again. Looking at I, we want to look at our order of operations. You know what, I'm going to go back a minute. I'm going to do an extra problem in here that is not listed because we had to add and subtract fractions that have the same denominator, or add and subtract fractions where one denominator divides evenly into the other. There are 2 other instances that you may come across when you are adding and subtracting fractions. So I'm going to do an extra problem or 2. Bear with me just a second here. What if I have 2/3 plus 4/5? Now both those denominators are prime. So if you have 2 prime denominators, how do you find the LCD? Multiply them, absolutely. So far we have dealt with having one denominator divide evenly into the other. The LCD is the larger number. If you have 2 prime denominators, multiply them to find the LCD. So in this case, the LCD is 15. So 15 is our new denominator. Now each of these fractions must change to be an equivalent fraction with the denominator 15. Again, just compare denominators. That's all we have to compare. What do you do to 3 to get 15? Multiply by 5. So if you multiply 3 by 5 to get 15, you have to multiply 2 by 5 to get 10. Again, what do you multiply 5 by to get 15? Times 3. So if you multiply 5 by 3 to get 15, you have to multiply 4 by 3 to get 12. So now we have like fractions. So our answer will have a denominator of 15. 10/15 plus 12/15 is 22/15. We can leave our answer as 22/15 because we can't think of a factor that will divide both 22 and 15. So it is simplified. Simplified doesn't always mean writing it as a mixed numeral. It's okay to leave it as an improper fraction as long as there isn't a number that divides both the numerator and denominator. In other words, as long as it doesn't need to be simplified. And a third possibility when adding or subtracting unlike fractions is when neither of the previous conditions exist, where you have 2 prime denominators or one denominator divides evenly into the other. So let's look at 9/25 minus 3/10. Well, 25 and 10 are not prime, so we're not just going to multiply them to come up with the LCD. And 10 doesn't divide evenly into 25, so we can't just choose the larger number. So what do we do? Well, there's a couple things we can do. If you were to count by 10s and count by 25s, what's the first number that they would have in common? So let's think about that. 10, 20, 30, 40, 50, 60, and so on. And we might have to increase that list. Count by 25s. 25 times 1 is 25. 25 times 2, 50. Up, there it is. It's right there, isn't it? 50 is the first one that they have in common. So our LCD is 50. That's one way to do it. Here's another way. Look at the prime factorization. 10 is 5 times 2. Both 5 and 2 are prime, so we're going to stop right there. 25. 5 times 5. Okay? So when we look at all the possible factors, because your LCD represents all the factors of both denominators, but the greatest number of times that any one denominator appears. Okay? So if you look at your prime factorizations, 10 is 2 times 5 and 25 is 5 times 5. Those factors are 2 and 5. So we know we're going to have a 2 and a 5. But actually we have 1 5 here and 2 5s here. Which is bigger, 1 5 or 2 5s? 2 5s. Remember I told you to think big when finding the LCD. So your LCD will have 2 5s. Not all the 5s that you see, but you'll compare. If one has 1 5 and the other has 2, you want the largest number of times that 5 appears, either in one denominator or the other. So therefore, when you multiply 2 times 5 times 5, you will get 10 times 5, which is 50. So you can use either method to find the LCD if neither of the two first methods work. 2 prime denominators, multiply to get the LCD. If one denominator divides evenly into the other, choose the larger. So now we need to write 9/25 as an equivalent fraction with a denominator of 50. 25 times what gives you 50? Times 2. So if we multiply 25 by 2, we have to multiply 9 by 2 and get 18. 10 times what gives you 50? Times 5. So if we multiply 10 by 5, we have to multiply 3 by 5 and we get 15. So 18/50ths minus 15/50ths gives you 3/50ths, which is in simplest form. Okay? Are we clear on how to add and subtract? Are we clear on how to add and subtract fractions? They must be like fractions to be able to join them or subtract them. Okay. Multiplying and dividing, you do not need a common denominator. Only adding and subtracting. Okay? Let's go back, since we veered from our review, let's go back to I. I'm on number 3, I. And I'm going to have to scoot that up. Following your order of operations, please excuse my dear Aunt Sally. Parentheses, exponents. Multiplication and division are of equal importance to each other, but more important than addition and subtraction, which are of equal importance to each other. In other words, if you have a line with all multiplication and division, you're not going to seek out multiplication first. You're going to just work it from left to right. If you have a line with all addition and subtraction, you're not going to seek out the addition first. You're going to work it from left to right. But in this case, we have a mixture. So we have to seek out the parentheses first, and we know that 13 minus 9 is 4. So I'm going to rewrite this line, but just changing and doing what's in the parentheses first. And 12 divided by 3 is 4. So now I have 2 plus 3 times 4 minus 4. And I have to take a second to look at this and see that I have multiplication. So I'm not going to dive right in and work from left to right and say 2 plus 3, because it's 2 plus 3 times 4. That multiplication must be done first. And do this in an organized way, line by line. 3 times 4 is 12. I'm going to rewrite it. So now I do have all addition and subtraction, and I can work it from left to right. 2 plus 12 is 14, and 14 minus 4 is 10. So the correct answer there is 10. Okay. All right. More simplifying using the order of operations. Well, actually we're going to be distributing. There's nothing we can do in those parentheses, so we're going to multiply and then we're going to combine like terms. So I'm going to multiply 4 times x and 4 times a positive 1, and I'll get 4x plus 4. Now next I'm going to multiply a negative 3 times x to get negative 3x, and a negative 3 times a negative 2 to get a positive 6. So 4x plus 4 minus 3x plus 6. Now I can combine like terms. So I have 4x minus 3x, so I can only combine x's with x's, not x's with integers. So 4x minus 3x is 1x, which I'll call x. And I have a positive 4 plus 6 is positive 10. X plus 10. That is the answer. This is not an equation. There's no equal sign there. So our answer isn't going to be 5 or 7 or x equals 7, because that's not an equation. These are not equations. We are only asked to simplify here. Looking at M, I have division, I have multiplication, and I have addition. Oh good, addition is at the end, because multiplication and division are more important than addition and subtraction. But multiplication doesn't come before division. This part is all multiplication and division, so I will work it from left to right. So 4 divided by 2 is 2, and 2 times 3 is 6. So 6 plus 5 is 11. Whenever I have all multiplication and division, I just work it from left to right, because multiplication and division are of equal importance to each other, but they are more important than addition and subtraction. Looking at N, I can do something inside the parentheses. I have 6 plus 1, which is 7. I can simplify that. So I'm going to rewrite that. So I have 2 sevenths times 7 and then minus 2. Now remember that I can write 7 as 7 over 1. So now I have 2 sevenths times 7 over 1. And that multiplication is more important than subtraction. But I can cancel any numerator with any denominator that has a common factor. So even though 2 sevenths won't reduce and 7 over 1 won't reduce, any numerator with any denominator, I can divide 7 by 7 and get 1, and 7 by 7 and get 1. So now I have 2 times 1 over 1, which is just 2. And 2 minus 2 is 0. So the answer there is 0. Okay. Looking at P, I have 3 to the 3rd power. 3 to the 3rd power. Now 3 is your base, the big 3 is the base, the little 3 is the exponent. We never multiply the base by the exponent. That's not what that says. The exponent 3 tells you that there are 3 3's multiplied together. So 3 times 3 is 9, and 9 times 3 is 27. So 3 to the 3rd power is 27. And 5 to the 2nd power, is that 10? Of course not, because we never multiply the base 5 by the exponent 2. That 2 tells you that there are 2 5's multiplied together, which gives you 25. But we'll get there in a minute, because I see parentheses. So 3 minus 1 is 2. So I have 3 cubed minus 5 squared plus 2 squared over 2 cubed minus 5. All I did was rewrite that, doing what's in the parentheses. So we said 3 to the 3rd power is 9 9. 3 times 3 is 9. 9 times 3 is 27. So we get 27 minus 2 5s that are multiplied together. 5 times 5, that's 25. Plus 2 squared, 2 2's multiplied together. 2 times 2 is 4. 2 cubed, is that 6? Of course not, because we never multiplied the 2 by the 3. 2 cubed, or 2 to the third power, means that there are 3 2's that are multiplied together. 2 times 2 is 4. 4 times 2 is 8. So we get 8 minus 5 in the denominator. So our numerator is all addition and subtraction, so we work it from left to right. 27 minus 25 is 2. And 2 plus 4 gives us 6. Over 8 minus 5, which is 3. Now 6/3 can be reduced. 6 divided by 3 is 2. So the answer there is 2. Evaluate each of the following expressions. Looking at A, will your answer be positive or negative? Not even knowing what x and y are. It says negative, the absolute value, the opposite of the absolute value. Your answer will be negative because absolute value means always positive, right? It's the distance away from 0 on a number line. Distance is always positive. So this says the opposite of positive. The opposite of always positive will be negative. So we know that the answer to A will be negative. Let's be sure. Let's check it. So we need to say that x is 2. So I'm going to rewrite this and I'm going to say negative, the absolute value of 5 times 2. I'm going to substitute in 2 for x and 3 for y. Minus 3 times 3. So absolute value symbols act like parentheses in that there's something to do inside them. So 5 times 2 is 10, minus 3 times 3, so it's minus 9, or negative 3 times 3 is a negative 9. So inside those absolute value symbols, I have 10 minus 9, which is 1. So I have negative the absolute value of 1, which is negative 1. We knew that our answer was going to be negative, and it is negative. Okay. Let's move on. Looking at properties of real numbers. Looking at the commutative property. Number 1 says the commutative property of addition and the commutative property of multiplication. Well, the commutative property deals with order. So an example of the commutative property of addition is 2 plus 3 equals 3 plus 2. We have the same add-ins in a different order. And 2 plus 3 is 5, 3 plus 2 is 5, so we have equality. The commutative property of multiplication, 3 times 4 gives you the same product as 4 times 3. That's a classic example of the commutative property of multiplication. If I could use one word that would sum up the commutative property, it would be order. Okay? So let's take a quick look at the associative property. The associative property deals with grouping. Grouping. So if I have 2 plus 3 plus 4, and I'm going to add 2 and 3 first, then add the 4, I will get the same sum as if I add the 3 and the 4 first, and then add 2 to that. Notice our groups are different, but we have the same add-ins. 2 plus 3 is 5, and 5 plus 4 gives you 9. And 3 plus 4 is 7, and 2 plus 7 also gives you 9. Not a surprise. Okay? Now, some people wrongly say, well, if it has parentheses, it must be the associative property. That is not true. Let me give you an example of the commutative property that does use parentheses. If I have notice that that is the commutative property of addition. My groups are not different. My groups are the same, so grouping is not affected. We have 2 plus 3, which we can call 5. So basically I have 5 plus 4 equals 4 plus 5. That's a classic commutative property of addition example. Okay? So there's an example of the commutative property of addition that uses parentheses. So you can't use the idea that if it's got parentheses, it must be either the associative property or the distributive. That's wrong. But notice that here, the groups are different. Grouping was affected. That's why that's the associative property. And in number 1, that example I just gave you, the groups are the same. Grouping's not affected. So only order has changed. Okay? You understand the difference between the commutative property and the associative property? Everybody get that? Okay. The distributive property also uses parentheses. We distribute this 3 over that addition, and we get 3 times x, which is 3x, and 3 times a positive 4 is a positive 12. So we actually distribute the 3 over each addend in the parentheses. We can see that we are distributing. So we start with parentheses. We have finished without parentheses when we have simplified it. Okay? State the property of real numbers that justifies the following statements, either commutative, associative, or distributive. So here you can see that x has been distributed with the y and x has been distributed with the z. So it is the distributive property. Now looking at C, it is not the distributive property. When simplified as much as possible, we don't get rid of our parentheses on the right-hand side. So it's not the distributive property. Is it the commutative or the associative? Remember that the associative property deals with grouping. So are your groups different? Are your groups different? Look inside those parentheses. Are your groups different? No, so grouping is not affected. So it's not the associative property. So it must be the commutative property. It's the commutative property of multiplication. X times YZ, which we can call YZ star. So we have X times star equals star times X. Since our groups are exactly the same, we can call them star, or heart, or baseball bat, or whatever you want to call them. So we have X times star equals star times X, classic commutative property of multiplication. Okay? X plus Y plus Z equals X plus Z plus Y. Now, are our groups different? Are our groups different? How are they different? Yes, they are different, but they are different because the order has changed. We don't have different addends, but the order has changed. So what property deals with order? The commutative property, and that's what that is. The commutative property of addition. Okay. And looking at F, Y plus Z times X. Well, we have parentheses on the left, we don't have them on the right. So I'm going to check and see if that's the distributive property, because that's what happens when we distribute and simplify. X has been multiplied by the Y and multiplied by the Z. So that x has been distributed over that addition. So it is the distributive property. Okay. All right. Number 6 says state the additive inverse, and number 7 says state the multiplicative inverse. What is the additive inverse? That is the opposite. So that when you add the number and the additive inverse, you will get 0 as your answer. What is the multiplicative inverse? The reciprocal. So that when you multiply the number and its multiplicative inverse, you will get positive 1. Now that's important to note. So really, it is the reciprocal including the sign. Because a negative times a negative will give you the positive that you seek, and of course positive times positive will. So an important part when you're looking for the multiplicative inverse, yes, it's the reciprocal including the sign. Okay? So let's go back and do this. The additive inverse is the opposite. So the opposite of negative 5 is positive 5. The opposite of positive 3/2 is negative 3/2. And the opposite of positive 2 is negative 2. In each of these cases, when you add negative 5 and 5, you get 0 as the sum. 3/2 plus a negative 3/2 equals 0. 2 plus a negative 2 equals 0. Because when you add opposites, you always get 0 as your sum. The multiplicative inverse is the reciprocal, so that when you multiply the number by the multiplicative inverse, you will get positive 1 as your product. So the reciprocal, remember, changes numerator and denominator, flips it over the fraction bar. So if you think of negative 5 over 1 as being negative 5, so that you have a numerator and denominator, something to flip, then the reciprocal, or the multiplicative inverse of negative 5 over 1, is negative 1 over 5. Remember, you have to multiply those two and get positive 1. That's why it's negative. And the reciprocal of positive 3/2 is 2/3. And the reciprocal of 2 is not 2 over 1, because 2 and 2 over 1 are exactly the same. Now flip 2 over 1, and you will get 1/2. Because if you multiply 2 by 2 over 1, you get 4. You have to be able to multiply the number and the multiplicative inverse and get positive 1. Okay, is everybody clear on the difference between the additive inverse and the multiplicative inverse? All right. Looking at number 8. Write an expression that represents each of the following statements. The number obtained when 3 times x is subtracted from the sum of y and z. Is subtracted from causes you to subtract in the opposite order. Less than also does. So when you see the words less than or subtracted from, you actually begin with what follows those words. So we have the number obtained when 3 times x is subtracted from the sum of y and z. We're going to start with the sum of y and z. How do you write the sum of y and z? Y plus z, because the sum is the answer when you add. So y plus z, and then 3 times x is 3x. This is y plus z, but remember we have to subtract in the opposite order. So we have y plus z minus 3x. I don't have to have those parentheses, but I do want to remind you that if you subtract more than one term, you do have to have parentheses, okay? So that if we had the number obtained when the sum of, if we had it in the opposite order, the sum of y and z is subtracted from x, we'll just say that. If we had the sum of y and z is subtracted from x, there are those words is subtracted from, which cause you to start with what follows that. So we would have x minus the sum of y and z. I can't write this because that would be wrong, because I have to show that I am subtracting the y and the z. So whenever you subtract more than one term, you have to have parentheses. So I really didn't need the parentheses here. It's okay to write this. But I absolutely have to have the parentheses here. X minus, open parenthesis, y plus z, close parenthesis. Okay? All right, simplify by combining like terms, if possible. Remember that you can combine x with x, but you cannot combine x's with integers. So I have 2x and I have 3x. So 2x plus 3x is 5x, and there is nothing that I can combine that minus 4 with. So I have 5x minus 4. In B, I have to distribute. So I have negative 3 times x is negative 3x, and I have negative 3 times negative 3, which is positive 9. So I have negative 3x plus 9 plus 2x. Again, I can combine x's with x's. So I have negative 3x plus 2x is negative x. And there's nothing to combine the plus 9 with. So I have plus 9. 5x squared plus 5y squared. Can I combine anything there? No, because I can only combine x squareds with x squareds and y squareds with y squareds. So it does not simplify. Okay. 5xy squared plus 2xy squared plus 2xy squared minus 6xy. Remember that like terms are the same variables to exactly the same powers. So we have xy squared, xy squared, xy squared. Those three are like terms. 6xy is not. So I can only combine the first 3 terms. So I have 5 of them plus 2 of them is 7. And 7 plus 2 more is 9xy squared minus 6xy. There's nothing that I can combine that minus 6xy with. So that is the answer. These answers are not x equal 5 or x equal 2 because we are only asked to simplify. These are not equations. There's no equal sign there. Only when there's an equation to solve will your final answer be x equal 5. Or sometimes no solution. Or you could have an identity. Those are your only 3 possibilities when solving an equation. And here we are with equations. Okay. Solve each equation if possible. So we want to get y on a side by itself. So on the right-hand side with the y, I have a minus 5, which I need to get rid of. So beneath minus 5, I'm going to zero out that column by writing plus 5, because we already learned that when you add opposites, you get 0. So if I add 5 to the right-hand side of the equal sign, I have to add 5 to the left-hand side of the equal sign. So I zero that out. So I only have y on the right-hand side, and 1 plus 5 is 6. That actually says y equals 6. And the reason why you add 5 to both sides of the equal sign, only once on each side, because your equal sign acts like a balanced scale. You wouldn't add 5 to every part there, because that would cause you to add maybe 10 on one side. So you only want to add 5 to each side. Remember that your equal sign acts like a balanced scale. Whatever you add to one side of the equal sign, you add to the other side. So c minus 11 equals 22. Get rid of that minus 11 by adding 11 to both sides. And we get c is equal to 33. Now the beauty of working in equations is that you can check your equations, you can check your answers and see if when you plug in y equals 6 or plug in c equals 33 into the original equation, you get a true statement. Y equals 6. Here's the check for that. 1 is equal to 6 minus 5. Is that a true statement? 1 is equal to 6 minus 5. Is that a true statement? Yeah, 6 minus 5 is 1. Let's check B. We said C equals 33. If the solution is 33, that is the value that gives you a true statement. 33 minus 11 equals 22. All I did was plug it into the original equation. Is 33 minus 11 22? Yes. So we did that correctly as well. Now we have negative 13x equals 26. So x is multiplied by negative 13. We want to undo that by dividing by negative 13. We don't want to divide out the x because we want our last step to be x equals a number. So we don't divide by negative 13x. We only divide by what's with the x. The x has to stay there. So we divide by negative 13. Again, if we divide by negative 13 on the left side, we have to divide by negative 13 on the right-hand side. So negative 13 over negative 13 is 1. So we end up with 1x, which we call x. And 26 divided by negative 13 is a negative 2. And here's our check. Negative 13 times negative 2, if I did this correctly, should equal positive 26. And it does, right? Negative times negative is positive, and 13 times 2 is 26. That's correct. And if you have enough time after doing all of the questions on your final exam, go seek out those equations and check them. 4 is equal to x over 5. I'm going to rewrite it so I don't write all over the original equation. X is now divided by 5. To undo that division, I use multiplication. So I'm going to multiply both sides by 5, but look where I put that 5. Because 5 can be thought of as 5 over 1, so 5 is really in the numerator. And if I multiply the right side by 5, I multiply the left side by 5. But in doing so on the right-hand side, 5 over 5 is 1. So I just get x on the right-hand side. 5 times 4 is 20. That says x is 20. So let's check that. 4 is equal to 20 over 5. Is that a true statement? 20 divided by 5, is that 4? Yes, so we did that correctly. (3y minus 5 over 7 equals 1). Now remember that I want the last step to be y equals a number. Y is inside the numerator. It's part of the numerator. But I have a fraction here, so I want to simplify by getting rid of that 7 in the denominator. So the first step that I'm going to do is multiply by 7. I don't have to distribute the 7 with the 3y minus 5 because I can do this. I don't even need to put those parentheses there. I could. But I want you to see that I am multiplying by 7 to get rid of 7 in the denominator. So if I multiply the left-hand side by 7, I have to multiply the right-hand side by 7. And I've gotten rid of the fraction. So I have 3y minus 5 equals 7. So y is part of the first term, so I need to get rid of minus 5. I will add 5 to both sides. Zeroes out that column, and I get 3y equals 12. Divide both sides by 3, and y equals 4. Y equals 4. So we can check that. Remember to substitute 4 in for y in the original equation, because maybe you did something from here to here that was incorrect. So 3 times 4 minus 5 over 7, if we did it correctly, should equal 1. 3 times 4 is 12. 12 minus 5 over 7 should equal 1. If you can't tell at this point that we did it correctly, we can go a step further. 12 minus 5 is 7. 7 over 7 equals 1. You can certainly tell there that that is a true statement, right? Okay. Remember that we're still solving equations. These are equations. They have an equal sign. That's how we know that they're equations. Now we can simplify by combining like terms on the same side of the equal sign. So I can do that on the left-hand side, and on the right-hand side I have to distribute. And then I can look at combining like terms, but I can't do that on the right-hand side until I distribute. So I have 5 plus 9y minus 3 equals 5 times 2 is 10, and 5 times a positive y is a positive 5y plus 5. So now I can combine like terms on the same side of the equal sign. I have 5 minus 3, which is 2, a positive 2. So I have 9y plus 2. On the right-hand side, I have 10 plus 5, which is 15. So I have 5y plus 15. Since I want my last line to be y equals a number, I would prefer to have my y's on the left-hand side, so I'm going to subtract out 5y that's on the right-hand side. If I subtract it on the right of the equal sign, I have to subtract it on the left of the equal sign. So it zeroes it out there, and I get 4y plus 2 equals 15. I want the y to be on a side by itself, so I'm going to subtract 2 from both sides. And I get 4y equals 13. Then divide both sides by 4. And my final answer is y equals 13 fourths. Y equals 13 fourths. Okay? All right. Next, I'm going to distribute 3 times 2 and 3 times a negative a. So I get 8a plus 6 minus 3a equals, now I have to distribute, 5 times a is 5a, and 5 times a positive 2 is a positive 10. The next step is to combine like terms on the same side of the equal sign. So I have 8a minus 3a, which is 5a, plus 6 on the left-hand side. And on the right-hand side, once I combine like terms, I have 10 minus 4, which is positive 6. So 5a plus 6. Now if I look at this, I have the identical thing on the left side as on the right side. This is actually called an identity. An identity. If at that point I don't see that, then I'm going to go about solving this. So I'm going to get rid of the 5a on the right-hand side, which ends up getting rid of it on the left-hand side. So it goes away. I end up with 6 equals 6. I have no value for the variable. My variable is gone. So once your variable goes away, you have two choices. Either you will have an identity, which means all real numbers will check here, or you have no solution. The fact is I have a true statement, 6 equals 6, for every value in the real number system. So it is an identity, and the answer is all real numbers. If I were to check a equal 1, I would get a true statement, and then go in and check a equal 2. I would get a true statement. A equal 3, a equal 3.5, a equal 4.02. Everything in the real number system will check. So again, as I said before we began working equations, that there are 3 possible outcomes when you work an equation. You could have one nice neat value for the variable that gives you a true statement, or you could have all real numbers, which is what we have here, Or you could have no solution. When you have an identity, when you have the identical thing on one side as the other, your answer will be all real numbers. Let's see what happens over here in I, because your third type of equation is when you have no solution. So we have 2 times s when we distribute and 2 times 2, which is 4. So we have 2s plus 4 equals, now we need to distribute again. 2 times s is 2s plus 2 minus 3. So we can combine like terms on the same side of the equal sign because positive 2 minus 3 is a negative 1. So we have 2s plus 4 equals 2s minus 1. Yes. Oh, I'm sorry. Thank you for letting me know. Okay. So let's go back over it. I distributed first. Then I combine like terms on the same side of the equal sign. So I need to get rid of this 2s that's on the right-hand side because I want my final line to be s equal a number, where s is on the left-hand side. So when I get rid of it, I end up getting rid of it on the right-hand side and the left-hand side. My variable goes away, and I get 4 equals negative 1. Once the variable goes away, again, your answer choices will either be no solution or all real numbers. But 4 doesn't equal negative 1. There's no value of s that would allow 4 to equal negative 1. So the answer here is no solution. There's no value of s that when you plug it in here in the original equation will give you a true statement. That's why there is no solution. So again, 3 possible outcomes when you work an equation. When you solve an equation, you could have one nice neat solution, one value for the variable that gives you a true statement when plugged in or substituted in. You could have all real numbers, or you could have no solution. When your variable goes away, we've subtracted it out, your outcomes will either be all real numbers or no solutions. No solution, excuse me. So when you have a true statement like 6 equals 6, it's all real numbers. When you have a false statement, it's no solution. Okay? Anybody have any questions? No. Okay, I am going to turn the microphone over to Miss Resnick, who you probably have seen in the lab. She staffs our lab.